need a note taker.
Okay, can we get volunteer to take notes? One or more? Or we could just volunteer the last person to enter the room. Oh, so close. Note taker, someone, anyone?
Nothing changed as far as you know.
Clerical error.
Honest, you have a table. You look like you're well positioned to take notes. Okay, you can take notes after you've presented those slides. Thank you. Yes. Okay. Okay.
Yes. No session ongoing. Yeah, I got the same thing.
Well, according to Mideko, I'm in the session. There's 33 other people in it.
Some people are retired, some people are.
QR code?
Not up here, on the back of the room.
Thank you.
All right. Those of you having trouble, can you try again? Lorenzo says he thinks it's fixed. It just worked. Okay. All right, thanks. Perfect. In that case, let's go ahead and get started. Note, we got the note takers, right? They were. Oh, that's right. Just one quick note to the note takers and everybody else, because of the start below the line, I put a line at the bottom of the agenda because I always stick the agenda in there. But for other reasons, if you could keep that top part clear and just go further down, that'd be super helpful. All right, with that, let's go ahead and get started. This is the Jose Working Group. We have the IETF note well. You will have agreed to this when you registered for the meeting and logged into Data Tracker. Please read it carefully. If you have any questions, feel free to ask anybody in leadership for resolution of those questions. some additional reminders that we would like people to also read. If you could take a few seconds to quickly read over these, that would be helpful. Do keep in mind that this is a professional collaboration and that we are maintaining a professional work environment. With that, meeting tips. And this is early in the week, so I guess it's still not too much to remind you of basic meeting etiquette. And with that, on to the agenda. We have divided the agenda into two pieces. The first is all of our accepted working group documents, and the second is the individual submissions that we've received. Is there any agenda bashing? Okay. So with that, sorry, this is the first half of the agenda, and then there is the second half of the agenda, which is the individual submissions. So with that, Mike, did you want to talk briefly about the fully specified algorithms?
Thank you, Karen. I'm Mike Jones. Ori Steele and I have worked on the fully specified algorithms draft, which most of you should be reasonably familiar with, having gone through two both active working group last call rounds. And Karen had asked me to talk about where the editors see the draft being at this point. Those of you who are on the list probably saw a period a little bit before the cutoff where I sent, I think, a dozen emails responding to everybody that sent in second working group last call comments with the intent of saying exactly how their input was addressed in the specification. And I do want to thank those who actively gave comments. Philippe, Brian, many others pointed out things that were broken, that were inconsistent, and we believe we've fixed those things. I will say this is a draft that it's interesting to do last call for, because in both rounds we got some mutually contradictory inputs. One set of participants would say, we like this feature, thank you for having it. Another would say, we don't want that feature. And, but, we've tried our best to thread the needle and come up with a consensus document that addresses the issues that we set out to address. And I believe Karen wants to give y'all a few more minutes to look at it. But that being said, as you could see from the emails, we did our darndest to address everything that came in.
Right. So basically, the deal is, I believe all of the comments have been addressed, and it's ready to go to the IESG. And this is your absolutely last chance to take a quick look and make sure that you feel the comments have been addressed in the way that is appropriate. So by the end of this week or early next week, we will be shipping it. So if you have any issues with it, speak up now. Anything for Mike?
Thank you.
So
Now I'm going to change hats and be a editor of the JSON Web Proofs documents. David Waite and I did a lot of work in the last few months on the drafts, and here's your guided tour next. So we've made both substantive, normative, and editorial updates, also burning through the issues list in GitHub. There is the GitHub link. We published the 06 drafts in September, where, for instance, Brent had asked for the ability to encrypt JWPs, so we did that in a way that should be familiar to how you encrypt JOTs. We reworked the descriptions of both the compact and the JSON serializations. DW put in work to describe the opportunity to have detached payloads and what the representation for omitting a payload would be. Next. But the big push this time was to start on our charter deliverable of having a CBOR serialization. So we've added in parallel to the JSON Web Proofs draft a CBOR serialization, and unsurprisingly required sort of rethinking parts of the structure of the document. One of the things that we did, for instance, is there was always a header parameters registry. Now the header parameters registry has an additional column, which is for the CBOR number that will be created for the header parameter. And I will say, let's see, what haven't I said already? We did the registry work next. As most of you know also that have been following the work, one of the primary specifications we're dependent upon is the BBS signatures. I finally have good news about that progressing in the CFRG. After more than a year of waiting, we got the CFRG cryptographic reviews. In fact, the floodgates sort of opened. Julia Hess or Hesche, not sure how you Germans can tell me how to say it. Hesse. Did the official review, and then Michelle Oru showed up with another one pretty soon after that. And there's been a response by the lead editor, Vasilis. There is a number of things brought up in the reviews that could be done to the draft, talking about blinded values, embedding payloads that are unknown to the issuer, pseudonymous identifiers, deriving verifier-specific identifiers from the payload, and more. And those of you on the CFRG list can follow along at home and even feel free to comment. I mean, back channeling with Vasilis and Tobias, they don't think that breaking changes are going to be warranted, but you know, your mileage may vary. They still have to finish the CFRG gauntlet, but at least that's happening. And if anybody's familiar with that or wants to add anything, maybe queue up and I'll be done in a moment and you can tell us more. Next. So we asked a question to the list which got a little bit of activity at first, but then died off, which is, should we keep a JSON serialization at all? Brian shakes his head, no. I'm kind of with Brian that I'm not sure that that was even warranted in Jose when we did it, although there were voices who wanted it, including Jim Schad and I think Richard Barnes. So it did go in the end. It's not widely used to my knowledge. And we really want to drive this not just off of a popularity poll, but are there use cases that actually require it? And if the answer to that is we don't have any, I think the conclusion's pretty foregone. But this is a point that you can resurrect that thread, or we can ask it again on list about whether we should have a JSON serialization. You know, the BBS saga continues. Yes? Sure, I'll take questions in line. Hi, Justin.
Hi, Justin Richer. Yeah, let's kill JSON serialization. There are things that it does that all of the other serializations don't do. I have not, in my experience, seen people actually need to use those extra features. And it causes a fair amount of confusion among developers about what is and is not Jose. So I vote with dropping it.
Right, and as an asterisk to that, I, as an author of an OAuth spec, the JSON Web Token, in the introduction said, this specification uses only the compact serializations in order to increase interoperability. And we've done fine in JOTS with that. Is there another question? Or should I
David?
Just wanted to add a comment there as an editor. The way that we redefine JSON serialization and compact serialization in draft 6 makes it clear that they're 100% equal representations. So there's no data that we plan right now to define that'd be JSON serialization exclusive. There was talk in the prior thread about unprotected headers, but the editors are nervous about that due to both the privacy focus and the multiple participant focus, that we would need much higher specificity on how those would work in an interoperable and privacy preserving way before I think we'd be willing to have that in the spec.
Let me expand on a point that David alluded to, that just like in JSON Web Signature, you can take a compact serialization, do no crypto, and do a mechanical transform to the JSON serialization. That's true here if we keep it. If we drop it, it's irrelevant. Any more questions, or should I proceed? So again, it's would be good for those of you, particularly with experience using cryptography, even if you're not a cryptographer, as I am not, to participate in the CFRG discussions about this. There are individual drafts doing extra stuff beyond the BBS signatures for blinded values, anonymous identifiers, and more magical cryptographic goodies, but these are individual drafts. They're not even adopted in the CFRG. So we're certainly not going to take dependencies on it at this stage, but you should know that that's floating around in the space. DW wants us to think about, do we ever optionally disclose header parameters, not just claims? Partly depends upon whether there's a use case for that as well. I mean, yes, we're all fine at specifying and maybe implementing mechanisms, but if they're not needed, I would rather leave them out. And one thing we didn't get done, just given our work schedules, is in the third draft, the JSON proof tokens draft. That's still JSON only. We haven't written down how to use the CWT claims in the CBOR representation of a web proof. That's to come. That's easy to do. It's largely mechanical. You could probably even imagine what that looks like because it's going to be parallel on purpose. Next. So there's plenty of opportunities for working group members and implementers to participate. We'd love to get a couple people building the CBOR representation and give us feedback on that. Kirsten, maybe you could do that as a weekend project. We keep asking the question, are there other algorithms, particularly zero knowledge algorithms, that we should consider speccing out in order to prove to ourselves that what we're doing is general purpose enough? Now, those might not go into the main specs if they're still pre-standard, because we don't want to take a schedule dependence on something that's an individual draft. But if we believe that an individual draft is exploring part of the space that will become a standard, it's probably worth writing a draft, an algorithm-specific draft to give that a try. Again, I am not a cryptographer, nor do I play one on TV, but some of you are, or you know cryptographers, and if you want to have a conversation with us about what additional algorithms we should look at, by all means, we're all ears. Now, in this modern day, it's pointed out to us again and again that BBS is not actually post-quantum safe. So while it's a good stepping stone to zero knowledge proofs, it doesn't necessarily take us to the post-quantum glorious future. So that's another area that we want to be eyes wide open about. And of course, we would love to have some interop testing among the, I think there's about 3 implementations right now. Next. All right, so for the rest of the time, just want to hear from you. What would you like to do with JSON Web Proofs, and what would you like to see us work on next to continue advancing the drafts?
Anyone?
So I was having a conversation last week with Torsten Lauderstedt, who's running the Sprindy competitions. He was suggesting that a future Sprindy, perhaps not everyone is familiar with the, so there's a Ministry of Innovation in Germany, which Torsten works for. And essentially they're responsible for, right now they're doing an innovation pilot around European EIDs. With wallet competition, he was suggesting that perhaps a post-quantum focused wallet competition or implementation competition, given that Google is pushing their particular notion of zero knowledge proofs. There are some people in BSI that are partial to, well, obsessed about BBS, and I guess other options. So there may be the opportunity for a government-sponsored competition. It would be
/ interop event.
Yeah. So, well, I don't know. First, it would take actually agreeing on what was to be interrupt, which is
Sure.
perhaps the first step in that. Orange has their BBS sharp stuff. There's I think 2 competing BBS theories in BSI. And I doubt that any of them actually have agreed on a container format. So figuring out with Sprind and BSI what exactly would be how, there are lots of theories that EU verifiable credentials in Europe should be using zero knowledge, though what that would actually look like hasn't necessarily been pushed in any interoperable dimension. So that might be an opportunity. And certainly those of us with wallet implementations need to better understand what a holder would do to perform the blinding operations for a BBS or for a JWP, given that some of that can be done, needs to be done in secure hardware, and other parts of it don't need to be done in secure hardware. And I haven't gone through all of the papers yet, but there seems to be differing implementation opinions about whether or not you can do that with an ECDSA signature, whether you need to use a Schnorr signature or ECDAA. And so how the wallet does the particular endorsement and whether or not JWP is actually compatible with one or all of those would be good to understand.
Indeed, I'll observe that, at least as a thought experiment, might be useful for a small group of us to look at the OpenID for verifiable credentials specs for issuance and presentation and ask ourselves, do we have the right structure in place to use a JWP, which might mean that we would need to do work there. It might also mean that we need to think about other additional header parameters or something in the JWP to convey the right application level information.
Right. Because ultimately, if this work isn't useful for European EIDs, it probably won't be generally useful.
Any other comments from the peanut gallery? Karsten's standing up.
Brian's thinking about it.
This is probably the most boring point I can make. Tildes and periods. This draft uses periods, and within the period delimited parts, you use tilde to delimit subparts.
That's correct.
As JWT uses tilde delimited main parts and periods within those parts. I believe this it would be a good idea to align that. If you think what I'm saying is not true, then maybe fix the text in SD, the selective disclosure JWT draft to say the right thing.
Oh, you are correct that in an SDJOT, and there's SDJOT authors in the room, if you have the proof, it's delimited by a tilde, so you're correct. I will take that under advisement. I'm not sure what to do, but I hear you. Brian?
Maybe I misunderstood the comment, but the tilde and period delimitation in SDJOT is there for a reason, and it is specified therein, both in prose, abstract made up syntax, and ABNF. So I don't know if that's not clear. I guess it should be fixed, but I do think it's clear. I was going to, when I was pondering coming up here before, was going to say again, what would I like to see you do next is I would like to see you all remove the, I don't know what you call it, composite EDSA signatures that are a very complicated way to do things that are already possible in SDJOT, in SD, CWT, and don't provide any additional privacy benefits. It only sort of confuses the landscape. So I know that's been pushed back on before, but.
And I'll repeat the reason it was pushed back on, which may or may not be valid, but editorially, we feel like, just as I was saying, if we had more zero knowledge proof algorithms, we would be more confident that we'd built a general purpose container format. I view those admittedly complicated EC standard curve based formats as a thought exercise in, can you represent those in the container format? Do we keep those in the final spec? I kind of hope we get another one or two zero knowledge proof algorithms and we drop it. But right now, I think it's useful for us to continue running the code that generates examples from those, even though, you know, I would then tell people, but use SDJOT if that's what you're doing.
As a general mechanism of proving out the structure, that makes a lot of sense.
That's why we've kept it so far.
In terms of confusing the marketplace and implementers and deployers down the road. I'm concerned about having it in there. So maybe it'd be great if there were other zero knowledge proofs that we could incorporate or look at, but maybe then an alternative would be to pull that stuff out into a separate draft as part of the proving out mechanism, but not have it on a path to standardization. Something to think about
Yeah,
before
we
you
can take
dismiss
that
it.
in consideration.
I think Karsten wanted to respond to my comments.
Yeah, you just said that it's already defined in SDJWT, and I agree with you completely, but it's defined the other way around than in this document. And I would like the two documents to make up their minds.
They're used for different purposes,
They are
but
two different documents, but
I hear you.
David, go ahead.
Yeah, a couple comments there. So the main reason that we use dot and tilde the way that we do, and rather than flipping them, is that we want just like in the other Jose documents, we want the content up to the first dot to be a protected header that can be parsed for metadata about the actual payloads. So algorithm, potentially thumbprints, who issued it, etc., about
KID.
processing. If in some cases it was up to the first dot and up to the first tilde, then that would be unfortunate for people who are getting have the flexibility to get arbitrary Jose documents and have to actually figure out what they received. That allows for things like look to the first period base 64-day code and look for TYP to figure out what type of actual thing you're dealing with. I believe the reason SDJOT uses it the other way is specifically their requirement to act as a bit of a post processor on JOT, that you can receive a JOT, cryptographically validate it, and then do supplemental work for selective disclosure. So they also may or may not have chosen the structure they did if they were creating something net new, but I think that was a lot of the motivation, is to get something they could feed into a post processor. And in both cases, we're limited by the number of characters that are URL safe that we're not already using in as part of the base 64 URL encoded data. I will say, in regards to the ECDSA and other algorithms, I'm hoping we get a bit more feedback. It is possible that we may still have that for issued documents in the final spec, that you can create them with ECDSA, but because we can have zero knowledge presentations based on those. And for people who might have seen a presentation that Google gave last week, there's value there if you can pull it off. In particular, the ability to use existing cryptographic hardware secure enclaves that will protect a ECDSA signing algorithm, but which you might expect 5 to 10 years before we really see hardware that would support BBS widely deployed. I suspect we'll see the first hardware quicker than that. So in terms of deployment, those algorithms might not be the best. I'm hoping to start getting feedback from people on what would be more efficient for those kinds of zero knowledge proofs. But I wouldn't expect a complete removal of classic algorithms, because they actually still can be quite useful for issuance.
David, what in that case would be the benefit of issuing that kind of document versus issuing, say, just an SDJOT?
Maybe an order of magnitude faster presentation on a cell phone.
Why?
Because of basically the circuit has to prepare the data in a certain way in order to be able to actually make proofs about it. So things like hashes of hashes, things without specific offsets, data that might be pre-known that in one case, but that you have to actually parse out in the other. There's just, you could say that a lot of the zero knowledge algorithms start to look like you're doing compute behind the scenes in a very low powered emulated processor. So again, I'm hoping to get feedback from people who have more zero knowledge expertise on what we can do to optimize structure for that. We haven't gotten that yet, but that is a potential possibility that we have the ability, since we're defining new algorithms versus say SDJOT, which is really limited to a specific class of signed hashes, that we can make something that actually is more powerful for certain zero knowledge constructs, even if we're using classical curves like ECDSA.
With that, unless there's any more comments from the floor, chairs, otherwise I'm done.
All right. Thank you very much, Mike.
Okay.
Next is Neil. Neil, do you want me to control the slides or are you?
You can control the slides if that's fine. Hi, so I'm Neil Madden. I'm going to talk about the draft to deprecate the JWS none algorithm and the JWE RSA 1.5. Next slide, please. So I'll do these in reverse order. So the RSA encryption algorithm, RSA 1_5, is RSA encryption with PKCS1 version 1.5 padding, which is really old, one of the oldest ways to do RSA encryption. And we've known for a long time that it has various security weaknesses. There's been various attacks against it dating back to 1998 and Bleikenbecker's attack. For a long time, it was kind of semi-approved for NIST and FIPS usage, but that is now stopped. So it is completely forbidden now for US federal use since the end of 2023. There's a draft in CFRG to forbid it for, or deprecate it for IETF protocols as well. And there's now pretty widely implemented replacements. So there's RSA with OAEP and elliptic curve Diffie-Hellman and a bunch of other stuff. So there are alternatives to this. So this has kind of had its day. It's got known weaknesses, known security weaknesses, and there are mature replacements for it. So next slide. And the other algorithm that this draft deprecates is the none algorithm for JWS, which has a sort of a certain amount of infamy about it, I guess. So this sort of disables all security. So whereas all the other JWS algorithms provide some kind of integrity and data origin authentication, the none algorithm obviously creates unsecured JWS, which has no security at all. And there's been a kind of fairly long history of security vulnerabilities because of people ignoring the advice in the RFC to disable it by default. And there's at least 10 CVEs registered, many of which are critical or high. There's a bunch of other security bugs that have been down to this, which didn't have CVEs, but nevertheless are still out there. My opinion is it's fairly easy to replace. I mean, it's essentially just some base64 encoded JSON. There's no cryptography involved, so you can do something. But as Mike has pointed out, some standards do build on top of this, or at least allow this algorithm in their specs. So OIDC and some ISO standards, I understand. So next slide, please. So the current status of the draft is it's been adopted by the working group. Thank you very much. I've just submitted yesterday the working group copy, so that's now up there, which is the same as what went to the call for adoption, but with some changes based on the feedback from the adoption call. So in response to some comments that Mike made, I've clarified that the algorithms are marked as deprecated, not prohibited. So the IANA registry for Jose has these separate statuses of deprecated and prohibited, and these are deprecated. So existing specs can continue to use them. They don't immediately break just because we deprecate them. And also, I think it was John who brought up, just to clarify, that RSA with PKCS1 version 1.5 padding is also used for signatures, and those are not being deprecated by this draft, so you can still carry on using those. So next slide. So the rest of this, I have just a couple of points in the draft I want to kind of highlight for discussion. These are kind of more opinionated bits, I guess, that are worth discussing. I'm kind of quite open to suggestions on corrections or removing these or anything else. So one is that the terms deprecated and so on in the IANA registry aren't actually defined anywhere. And so I think there is some confusion about what deprecated means. I think this is also, there's some text in the fully specified algorithms draft around this as well. And this tries to put in some guidance here for implementers on what this means. So it's worth having a look at that. And if anyone disagrees with what's being put in there, then please speak up. And next one. Next slide, please. And the other thing that's in the draft, which definitely deserves some discussion, was updating the instructions for the designated experts to specify. At the moment, there's no sort of baseline requirement for what is a good algorithm to go into Jose. So it specifies, I've got a couple of paragraphs in there which say, you know, if you want to be a new JWS algorithm, you should meet these standard security goals, and these should be standard for any cryptographers in the room. Hopefully they'd all agree that these are kind of standard baseline security goals for these things. So for signatures, it's existential unforgeability under a chosen message attack. For key wrapping, key management, I think Jose calls it, then it would be indistinguishability under an adaptive chosen ciphertext attack. And for the content encryption, it would be authenticated encryption, which I believe all of the algorithms now in the registry, apart from the two being deprecated by this draft, do reasonably meet those goals. And I feel like it's a good baseline. But again, this is a much more opinionated section of the draft, and feedback would be great.
Okay. Can we go to the queue, Mike?
Yeah, Mike Jones. I'm actually going to talk about your last two slides. I just wanted to say that you're using the terms deprecated and prohibited in exactly the way they're defined in the fully specified algorithms draft. So that's in sync. And so once we get that out, I mean, those terms go way back to Sean Turner when he was area director. And he suggested that distinction at the time 12 years ago. But so that's all good. To your third bullet on this slide, there's already text in JSON Web Encryption that requires only registering AEAD algorithms. If you want to put that in the instructions to the designated experts as a concise guide or something, that doesn't bother me, but that's already required. Now, unfortunately, because I didn't keep that, but that's a whole another discussion for another room.
Okay.
Thank you.
Yeah.
Go ahead, John.
Yeah, John, as an individual, I was just going to say the opposite of Mike, that this has a different definition of deprecated than, than the fully specified. This is the text you have here is harder than the deprecated in the other draft. I don't know if that's a problem. I think this should be a harder language for these algorithms. And then your next slide is discussion of COSI. I assume that is about the review instructions. My understanding is that none of the PKCS and non-algorithms exist in COSI.
Yes, I don't know. It was, so next slide then, please. This one. So this was something that was raised in the when the draft was originally proposed, not during the adoption call. Somebody said, "Oh, we should do this for COSE 2." I'm not actually that familiar with COSE, so I haven't checked whether these algorithms even exist there or not. But yes, so there was a discussion about whether, I mean, we do have several drafts now in the working group, which are applying to both working groups. And whether they would need to be in both.
Sophie, or I guess, Mike, were you just responding to the COSI? Well, go ahead then.
I did the exercise yesterday, actually, to look in the COSI registry to see if RSA 1.5 is even specified. It is not. I did do the draft that added RSA signatures, but you're not touching those, and there's no none in COSI. So with respect to the particular mission of your draft, there's nothing to do in COSI to my read.
Yeah, I just wanted to say thank you so much for actually making something that deprecates none and RSA 1.5, PKCS 1.5. One problem is that it doesn't really fully address the whole original sin of having the algorithm in the token, but I don't think that we can do that. So I love like at least an incremental progress on this. And I think the other thing with the properties that you would like for an for chems and so on. I think Deirdre is there. So if I'm at the mic, I think obliged to mention that. Have you considered adding binding properties to the required properties as well?
I haven't. It's a good question. I guess if we added binding properties like key binding and so on, we'd have to consider whether the existing algorithms meet them or not. At the moment, I'm just looking for something that's like an absolute baseline. Anything reasonable will meet this bar kind of thing.
So, Carsten Bormann, on this particular slide, Mike answered most of it. You have another slide about minimum requirements, which actually I like. So that's something I think we could use in COSI as well. However, I have to point out that COSI is also used for some applications on constraint devices. And there we sometimes have things in there that are not AAD. And that's a long discussion. There are lots of danger things pasted to that and so on. But for things like firmware upgrade, that's sometimes something you want to do. So these minimum requirements probably wouldn't be absolute requirements, but would be requirements that if they are not fulfilled, require very special handling and lots of information that this is for a particular application, not for general use.
Okay.
Go ahead, Hannes.
Is that everyone? Hannes.
Yeah, we also in COSI we also have the UCCS, which is conceptually similar to algorithm equals to none, right? In some sense.
Thank you, Hannes. I didn't want to complicate this because we definitely want to get rid of elk none. But for people who want to use something that solves the same problem, but not by looking like a JOT, but by looking something different, we have the equivalent construct called an unprotected CWT claim set, or UCCS. And the newest version actually has an appendix that says, oh, by the way, you can use the same CTDL to define a UJCS. So that would just go in everywhere where you have elk none now.
Okay, there's nobody left in the queue.
Mhm.
I,
I think from those discussions on Jose, it sounds like there's enough difference between Jose and Jose around this that probably having the same draft do both is not a good idea.
I see a few thumbs up. All right, so with that, comment on the list. Need people to review this and comment on the list, and it sounds like it's pretty mature.
Great.
Hi. I'll be talking about I'm sorry, I don't have slides today, but I'll be talking about the PQ chems for Jose Jose. So the draft was first presented at Brisbane, and recently we got a working group adoption consensus, and I think it was we published the new draft yesterday. There was not many changes from the last meeting, but so now that the new working group draft is available, I would request everyone to have a look. Please provide some comments. And there was, I think, one issue pending in the mailing list. I think somebody asked HPK, why we're not using HPK. I think we have an HPK draft already with Jose, which Hannes will be presenting in a while. And other than that, there was no open issues in the mailing list. So I would request people to review the draft and please provide your comments, and we'll address that.
Okay, Brian.
Brian.
I may have been the one asked that question.
Okay.
But I, if it was me, I intended to frame it a different way. Is that all throughout the discussion of the HPKE for Jose, it was stated over and over again that this is the only way we could possibly have post-quantum chems for Jose, and that there was no way to do a key encapsulation method on its own inside of Jose without HPKE. And then later on, we came along and we defined a draft for chems in Jose, completely independent of HPKE. So it feels to me like there's a lot of duplicative work here, and seems like this should probably be the only construct that the working group, and Jose for that matter, pursues. But I may have missed something obvious in this construct. But
Okay. Yeah, Hannes, you want to take that? Yeah. Okay.
I think, like in general, there are different cryptographic building blocks, and different people want to use different building blocks. Some people have, when we started with the HPKE, that is one. There's also ephemeral static differential you could use, or different variants of it. So there are different ways to do to build sort of your application security. So I don't think anyone has been saying you have to use HPKE from now on. It was just a very popular technique for some people, and that's why we worked on it. But other people want to use, like, for example, if you want to go into you start fresh and you just want to use post-quantum crypto, then use some of those mechanisms. Why do you use HPKE? But if you come from the HPKE work and want to transition over to post-quantum, maybe you want to deploy the hybrid mode first. It's not a big change for your deployment there. So it depends where you come from, what your preferences are, how you want to use it. Like it's the same like with elliptic curve cryptography. Not everyone wants to use this the NIST curves, for example. If some people want to use something else. Let them do that. Let the market decide what they want to do.
I don't think those comparisons quite line up well. And with ECDSA, ephemeral static, which we do have defined in Jose already, it's been there for 12 years. And actually it only defines the NIST curve. So the market figured it out. I don't know, Germany hates it, but they haven't gone to actually defining their own curves for it. But it was more of my observation when people were saying the HPKE, I have a hard time saying it, so doesn't fit well at all within the constructs of Jose. It's just like the mechanisms don't line up very well. The response that I saw and received was, oh, sure, yeah, but we absolutely have to do this in order to facilitate post-quantum chems because it's the only way.
Yeah, I think the discussion was more towards hybrid moving, and this is actually the pure PQC chems where we're using directly the NIST specified algorithms. I think the discussion started from the hybrid side that it would be easier to incorporate the hybrid versions, the PQT hybrid versions with HPKE, and that's where I think the discussion started from. But if you want to use just pure chems or pure PQC algorithms, using HPKE may not be right. Yeah. So, yeah.
Would it not be possible to do a hybrid chem using the same mechanism?
With HPK or
with just whatever the chem mechanism?
Yeah. There's another draft which will be presented as well. So.
Well, no, that we shouldn't be developing first of all, the working group itself has come under a lot of criticism for having like too many options, a la carte, stuff like that, and making it difficult for developers to decide. And we really shouldn't be developing parallel constructs to facilitate the same functionality. I don't see a justification. I haven't heard one for doing HPKE and Jose at all. No, it's not about whether I like it or not.
Because every meeting you come to the microphone and tell us you don't like HPKE, and you think that's like, does that reflect the group? Like on the mailing list, you see a lot of people saying being in support of HPKE. It's you don't like it, and that's okay. It's fine.
HPKE is the right way of doing asymmetric cryptography in this context.
Please use.
You can also.
Microphone.
Okay. I'm Sophie, cryptography at Google. If you want to do asymmetric encryption, you should use HPKE. It exists for that reason. That is the standard that tells you how you turn the fairly abstract standards that NIST has written that define chems and so on into something that you can actually use to encrypt something. You don't need it only for hybrid. You can use it for hybrid, but you can also use it for PQ only. HPKE is a generic thing that turns a chem into a hybrid encryption scheme. And I think we should have less different ways of doing that, since that leads to a lot of incompatibilities, leads to potential vulnerabilities if you do it wrong. We have done it once correctly. It took way too long to get HPKE going, unfortunately. But yeah, we should use HPKE for everything, everywhere, all the time. We should not try to do anything else for hybrid encryption, in my opinion.
Okay, but I think this draft is actually for pure PQC chems. So I think, yeah.
Even for pure PQC chems, just
okay.
use HPKE. HPKE is a generic way of encrypting things. You can use it with MLChem if you want to.
Yeah.
So I wouldn't put MLChem into JWT on top of having HPKE already in there. It's like you put it in there twice. And MLChem, HPKE is something that encrypts generic messages, and it put a lot of work into doing that right. So I do think that we should just use HPKE for that. HPKE already gives you pure PQC, gives you hybrid PQC, non-PQC, gives you ECIES, which I know JWT already has their own hybrid scheme. honestly, yeah, we should just use HPKey for that as well, but that ship has sailed, unfortunately. But yeah, for everything new, we should always use HPKey. HPKey exists for that very reason, so that we can turn a generic chem into an encryption scheme. Whether that's MLChem pure, whether that's ECIES, whether that's X-Wing, use HPKey for that, in my opinion. It makes stuff way simpler to reason about, means that we don't have to analyze that all the properties are correct in the specific way that we did the hybrid encryption scheme here. HPKey does this already.
Sophie, in the case that HPK is being used to encrypt a symmetric key, I was trying to talk both ways. The majority of the currently defined HPK scheme in Jose uses HPK to encrypt on a symmetric key in order to do the symmetric encryption. So it's sort of like a double layered hybrid encryption scheme. Is it?
Joe, Joe, speak, please.
Yeah, so I think it sounds to me like these two things are really trying to do the same thing. And I don't know that I have too much of an opinion on if we should do one or the other, but I think I agree with Sophie that I think HPKA is, in general, probably the way to go. But I haven't looked at this scheme, so I don't know. But it does sound to me, I mean, it's a little confusing because hybrid is in both terms and they kind of used in different ways. But I think we should take a close look and make sure that we're not duplicating effort here. Thanks.
Sure.
So John Bradley is an individual. So I'll stick my neck out and kind of agree with Brian in that I think what I understand is that having too many ways of doing the same thing is confusing to developers. Now, there seems to be a differing opinion that if we were to only have one way to do this, which way would we have? And I don't necessarily agree with Brian there. I'm still open to influence. So we could decide that we were only going to have HPKE, which might make Brian happy in that we would only have one way, though it would be potentially, in his opinion, the wrong way. But or we could go with the CAMs without HPKE, which would make another group of people unhappy because that would potentially give more options for people to misimplement things. But I guess we need to figure out, are we going to proceed down these two roads in parallel, continue down the two roads in parallel, or are we going to actually consider consolidating into only giving people one way to do this?
Sorry, I'm not on the Meet Echo. I'm Deirdre from Sandbox. I'm looking at the document now. In direct key agreement mode, the output of the KDF must be a key of the same length. In direct key agreement mode, when it's employed, the shared secret is the content encryption key. Use the same length. MLCAM has 32-byte shared secrets for all parameter sets. That may inform what you want to do here, but you cannot put a 32-byte shared secret key as your content encrypting key if the size of the input key for, I don't know, cha-cha, big block cipher, whatever, does not match. This implies all the decisions that HPKE made to solve these problems of separating these things. I do not think having a different content encrypting key mode thing is useful in the world where we have HPKE because it's solving these problems explicitly and separating these concerns. So that's directly in the draft.
Okay. But yeah, I mean, I think we can probably deliberate more in the mailing list, but yeah, I'm also the co-author of the HPKE draft as well. So either ways is, I mean, we'll be working on both, but anyways, yeah. Anything else?
Brian, you're not in the queue, right?
I was sort of, but
Go on, have them.
I think one or the other would be good. I don't think we should be pursuing both paths. That
Okay, so if we could do one or the other, and the one would be HPKE, you probably would be able to live with that.
yeah, I do think
Okay.
we should look closely at whether it's worth jamming HPKE into JWE or whether it would be better to actually define HPKE over Jose type constructs
Right,
in general.
But whichever way it would go, you would prefer to have a single way as
Yeah.
opposed to two.
Correct.
Okay. Great.
All right, thank you. Hannes?
Yeah, thanks for setting up the stage on this topic. Feels so much better now. Warmed up already. Yeah, so talking about Brian's favorite topic, cozy HPKE. There are, so you've heard something about the history already. If you go to the next slide. So from the mailing list discussions, there are, there are two modes that we have in there. One is called, at the bottom of the slide, we call it integrated encryption, which is a mode that directly encrypts the plain text based on what HPKE sort of provides us, or with an HPKE derived key. That's called integrated encryption. The key encryption goes through a layer of indirection, if you will, by encrypting a content encryption key, which is then used to encrypt the plain text. That has the advantage that if you have multiple recipients, you can encrypt, you can generate an encrypted payload and encrypt the content encryption key to multiple parties. That's the difference between those two. Of course, they look different in like the encoding consequently, but feature-wise, one only supports a single recipient, the other one supports multiple recipients. And the question I'm going to ask later on, which is what we have been struggling with on the mailing list, is the first question is, do you like that, or do you need that feature for integrated encryption, which is the single recipient, sort of like you could think of it as the optimized version of the key encryption version, or do you want the latter, or both? That's the first two questions. And then there's a third question, a follow-up question, which relates to the context information structure, which is somewhat orthogonal to this, and we'll come to it later. So I've talked about the integrated encryption and key encryption as a mode in this last two meetings. Raise your hand quickly if you recall again what this stuff was about. Oh my God. Okay. Okay. I'm talking to an informed audience here. Okay. Yeah. Also, and Philip woke up. Good. That's difficult. That may not give me. Yeah. So okay, but I'll ask you questions anyway. Just to keep that in mind, that maybe not everyone remembers what this was about. Okay. Next slide. Oh.
When do you
Philip.
Do you want to go now or later?
Yeah,
You'll go at the
go,
end, okay.
go for it. Yeah.
I would strongly recommend just getting rid of integrated encryption as a different way to do it, and always encrypt in one way. It just makes everything so much simpler. Yes, you may look like you've got an additional key derivation function that you wouldn't necessarily need, or a key wrapping or whatever, but it just makes things, you've only got one path to analyze, and the difference between doing the integrated versus the group in terms of working out whether you've screwed up is actually quite a lot. So I just say always do a key wrap. It just makes things better.
Okay. Fair. Good. So you, I would recommend you vote with no here. So encoding wise, if we were to support integrated encryption, you have to sort of like with the fully specified algorithms, you have to use that string. It basically indicates like obviously that you use HB key. We have sort of like this triple that HB key defines is sort of the encryption algorithm, the curve here, and also the KDF as well. And so the encryption value based on what Jose says or the JWE says, it would be direct. And yeah, that would be it. That has received some scrutiny from the mailing list. And I show you what the other option is, the other question, just in a second, so you see the different encoding style, if you care about that. If you go forward one slide. This is conceptually fits more naturally into Jose and the JWE because it uses the pattern that we know from ephemeral static Diffie-Hellman, meaning that there's a recipient field where this goes in, where the data goes in the encryption value that is used to encrypt the plain text is any of the specified AAD algorithms, which we had heard about previously from Mike's and from Neil's presentation. And this is sort of like, we use HB key as the way to do the content encryption key, the KEK in encryption. So the key to encrypt the KEK is the output of the HB key uses the KEK as the plain text and encrypts that. That's what Philip has just been talking about. So those are the two questions which I would really appreciate you give me or the authors and the whole group some feedback on, whether you either want one or the former or the later or both, depending on your use case. Can the chairs ask the question for like 1 and 2?
Go ahead, Brian.
Would you go back one slide real fast before we get there? The ENC value of dir, that strikes me as a direct contradiction to the requirement that the registered symmetric encryption algorithms have to be AEAD, because nothing is not AEAD. So that I don't think this is actually technically possible within the constructs of Jose as it's defined now.
That's why this document updated. That's that's what the last bullet says.
Yeah, don't do that, please.
Then say no here.
Okay, I will, but I also think
well, we can define the semantics of the value in the way we like it, right?
We can, but realize you're building on a substrate of existing functionality and standards that make certain assumptions about the way things work. And so not dissimilar to like None, introducing something like a dir AEAD symmetric encryption algorithm provides additional opportunities for unwitting developer mistakes or integration mistakes between layers.
Fair enough. So the reason where this came from was actually in COSI, where we initially started this work. We initially only had the second mode, and then people came along and had use cases where they said they don't want to have this extra layer. Of course, it introduces some extra layer, some extra wrapping, and so they wanted to have sort of a more compact way, and that's where it came from. And we sort of transition it over. And if if you say this is not useful for you, good, say no.
But again, as I said earlier, I think it might be worth considering actually defining a serialization and a construct that's unique to this, that is a good match for JSON and base64 encoded constructs over or under, I don't know, for HBKE that specifically does that, rather than sort of cramming it into the constructs of JWE. Because I do think that particular use case is valuable, an integrated encryption type mode. But and it's not that I don't like HBKE, I don't like that it's being sort of forced into these constructs where it doesn't fit very well.
Yeah, so like in your case, like you would, if you flip forward one slide, that mode, it's not just, you can also easily use it for a single recipient. If you just put one recipient in a structure, then it would nicely align in that sense with what we already have. And it would, the cost in quotes is double encryption. Whether that would be a big thing, because the KEK is obviously not super long, so encrypt the KEK and then use that to encrypt the payload. Is that a big deal? Not for me. But when it was brought up, it was apparently for some people. I remember Richard Barnes, for example. He's not here in the room. I don't see him. But that's where we ended up. That's why we are here where, at this point in time, and asking ourselves that question again. And it's a fair question. Another one?
So I'll just make the observation that Jose and Coze are quite often used in different environments, and the optimizations necessary for a constrained environment that might be using Coze might see a benefit that really isn't meaningful in those sort of larger scale environments, which are doing base 64 encoding and don't have those memory constraints. I don't know that I mean, we try and keep Coze and Jose aligned. It may be that perhaps the extreme optimization doesn't necessarily need to be replicated in Jose. And that is an option.
Yeah, take that into account as well. Whatever your use case is. Yeah, certainly.
All right, Neil.
I just want to walk out of the room with a decision on this because I don't want to drag this on forever.
So the only other point I was going to get, which is also in the chat a bit, is that HPK at the moment is kind of single recipient, and you can do this kind of key wrapping, but it's more efficient to do it in HPK itself. But there's also, when we start looking at the authenticated chems, which is not the primary reason I think that HPK is being looked at here. That's for PQC, but the drafts I think do bring in the authenticated chems, and there is this issue of the lack of insider auth security of HPK's authenticated chems, which I think for some of the use cases that things that Jose is used for might be a problem. So, for example, if you encrypt the same access token or something to 3 different APIs, then any of those APIs can decrypt it and then turn around and create forgeries to the other 2 APIs, kind of thing. So that is something that needs to be fixed somehow, and we have like MLS fixes it at a higher level, building on top of HPK, and so I don't want us to just accidentally add something to Jose that introduces a potential security issue that we need to just sort of coming along for the ride when we wanted something else.
Yeah. It's a topic that I didn't want to bring up, but yeah, you're right that there are different modes in HPK, and some of them are the base mode, which doesn't do authentication, and then there are also authenticated modes, which we talked about, and this is probably a discussion for future, but so far the story was that you would use the base mode, and if you want quite naturally is digital signature with all of this, or let's say Mac, then you apply that using the regular Jose Coze techniques and be done with that. But I'm happy if I make progress on those topics, and then discuss some of those other modes at a future point in time. Like I have to start somewhere after all, right?
Yeah, somewhere, yes. Okay, so the authors have asked us to do these 2 questions. The first question, does the room feel comfortable enough with the, I see nodding heads. Okay, I'm willing to do informal questions and see what you end up with. Yep. All right. Um,
Are we humming or doing the
Hands up.
oh, I guess we're doing the hands tool. We have not pre-prepared the questions. So look at the slide and then you know that you're doing topic 1. So there you go. Topic 1 has started. And of course, you can no longer see. Oh,
Yeah. Well, the topic 1 is
it's very small over there. You can see
Okay.
it in data tracker. It's the algorithm name.
So if you say yes, you want support for the integrated encryption mode. In this form.
Right.
Yes. Well, not in another form
Right.
that we haven't written up, so then problems start. We can ask that as a side question afterwards.
This is why I want to make it an informal poll, because I feel like our questions are not clear enough yet, although they're clear to some. Maybe it's just me. But the questions are in the slides, which are up in data tracker. Yeah, so basically the no opinions have it. So unfortunately, Hannes, I don't think you're getting a clear answer at this stage.
Okay, but maybe the story is different for the key encryption. What?
All right, so now we're moving on to the call topic number 2, the key encryption mode. I didn't. If I had gotten the slides in advance, I would have put these into questions for you.
That's okay.
So here's question number 2 on the key encryption mode. What is the music that goes in the background? Dee, 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 dee. Is it Wheel of Fortune or something?
Okay, that's
All right.
well, it's a little clearer than the previous one.
Yeah, I think it's either yes or no opinion in this stage. So that should give you a solid way forward on that one.
Yeah. Okay. We obviously have to take that to the mailing list and
Right.
Give other people who are not here a chance to voice their opinion. But at least my sense is people prefer the key encryption mode, and with the other one, they are all over the map.
Justin Richards. So since this was an informal poll and not a consensus call, I would recommend that the authors take this as feedback to go run in this direction until somebody gets mad at you. Because it's easier to have something concrete to look at and pick apart the specifics than it is. That would be my recommendation, given sort of the
right. I hear that, but I think there's been some pretty strong opinions. Right. Exactly.
Brian is already mad, for the record. But, okay. But I know I would like to see some
on topic 2. I agree
stuff
with that. Topic 1, I think it was much more questionable. So I think all of you all that care really passionately about this need to go off in a corner and duke it out and come back.
I don't disagree with the chair's statement there.
So I guess it comes down to people aren't convinced that we need an optimized mode. And if we do have an optimized mode, whether or not the proposal you had on the slide was the best way of doing that.
Yeah, I think that's a good way of phrasing it. Yeah. Good. This is a little bit more technical topic in some sense. So these key encapsulation mechanisms also, or not require, but typically use input into the key derivation function in different forms. So it's typically the algorithm identifiers, it's information about the endpoints, it's about the key length, potentially some salt and some other data. And COSI, as well as Jose with the encryption capabilities, has added structures and discussed this topic. So there is a provision for this already present. But the question is, what should the document say and that the slide shows what it currently says. It basically says, by default, HPKE doesn't have any sort of empty set of values, and the application developer has to provide something, for example, via the APU and the APV. So those are the two parties in that dialogue, and there's text in this reference section of RFC 7518 on how to incorporate this data into the key derivation function. We have been both in COSI and in HOSI, we've been dancing around on how to word the text and phrase frame it to say, like, do you mandatorily have to include some information, or you optionally like leave everything blank, you don't do anything, or it's developer provided. So we have been sort of had different stories over the time, and so it's a little bit difficult. So this is what we currently have, and like it's obviously a big ask to provide feedback on this, because ideally that would be a question almost to cryptographers to say, like, what's the right way to do it. But throughout the IETF, I think this very closely reassembles what some other groups have been doing, like in LAMS. And so, yeah, I see Joe.
Yeah, Joe Salloway. I think, I was going to get up here and say, well, we should, if HPKE, and I'm kind of speaking a little bit uninformed because I haven't looked at this recently, but if HPKE gave you a place to put context information, it seems like it would be a good thing to do to use that, because that would hopefully figure into security proofs that have gone into HPKE. But then you mentioned that LAMPS and other groups may not be using it in that way, and presumably they are also looking into the same issues. So, I mean, it seems like if the place is there for it, we should use it. But obviously, what you said about getting some cryptographic analysis of this is probably the most important part.
Yeah. So, for example, HPKE also says, like, you can put endpoint identities in there, and also the NIST specification, NIST special publication 800-53 or so, or maybe 63, I don't know, says like endpoint identities. But then there's the interpretation of what the endpoint identifiers are varies. Some people put the public keys in there. In HPKE, you don't need to do that because that's already done there for you. But if you put, for example, let's say the endpoints actually, let's say, have the shape of an email address. If you put that information in there, that changes sort of like the properties quite a bit. But of course, we don't know at the level of COSI as a building block. We don't know what the application ultimately will be and what these identifiers are. So it's a little bit tricky for us to say precisely on what to put in there, because it could be used for OAuth, it could be used for like an IoT system with firmware updates. So it's a
Can you say that? I mean, I think you're right. It's going to be application defined. I mean, the identity is an application defined construct, but where you put that in the cryptographic construction you can have a standard place to put that. And there's some attribute that you put in.
Yeah, that's what we say in there, but be careful.
So, all right. So, Brian, there's a lot.
Okay, that's okay.
Oh.
I'm behind Brian and Russ.
Yeah. So, Brian, you're next. The one thing while you're getting up, we have suddenly a fairly long queue, and we are moving into the individual submissions. I think this is a working group draft, and it needs the discussion. So the other presentations might be a little shorter. Go ahead. Keep your comments short.
Short. Okay. And uninformed like Joe before me. Just a reminder that APU and APV are defined in the context of the ECDH algorithms themselves. So either you need to be very clearly defining reuse there, or better yet, you could just define whatever you need that maps very nicely into HBK rather than trying to
Yeah.
pull it over.
I
know that doesn't answer the underlying question about what needs to go in there, but
yeah.
I just wanted to make clear to you that LAMPS is not doing this.
Okay.
We looked at it, ejected it because it doesn't fit with CMS where it is inherently multiple recipient.
Okay. Yep. Okay. Thanks, Russ.
In the context of some of the previous items of PK chems and hybrid chems, if you are swapping out the default chem in HBKE, which is DH chem, it automatically quote commits to the public keys, the DH public keys, as part of its internal KDF. If you swap that out for a hybrid or ML chem, it does not. So if you care about committing to the public information that you're using in this key setup, like the ML Chem public key or another Chem public key, ML Chem, it's probably less relevant, but once upon a time it was extremely relevant. You might include that in the HPKE setup info because it will be fed into the key, into the KDF schedule of HPKE and get committed to, or maybe a Chem ciphertext or anything like that.
Yep.
So these may be highly relevant to using different chems in HPKE in this setting.
That's good feedback. I personally, and maybe that's just me, I'm more interested in binding it to the application layer identities rather than the public keys themselves. But okay, that's.
Yeah, Phil, yeah. Echoing what Russ said, I mean, I went through this whole thing about what the hell do you use APU and APV for only 3 weeks ago. And I spent a good week going through all the documents or whatever. And my conclusion was that it's just not relevant to Jose and Jose because the stuff that you would bind are already being bound in other places because you've got a manifest. I don't think that I think that the cogs that we don't happen to need.
Okay. Yeah. Yeah, it's a little bit sophisticated attacks. So yeah, you may be right, but you know, like there's always the risk that some creative attacker comes along and then we toast. But I don't know. Maybe I'm too careful here. Okay, I feel I have worries if I ask that question, there won't be a
No,
meaningful,
we're not asking that question, so I'll stop it for you. We'll take the rest of the conversation on this document to the mailing list and move on to the next
and I will
topic,
compress that really,
which is for you as well. So.
Okay, there's also a little bit history here in one of the initial versions of the COSI HBKE documents. We registered a number of algorithms, and Deirdre at that time worked on a sort of a hybrid chem for HBKE and registered that one, and then I'm sort of work in progress. And so we initially put it into as a register, or we registered that algorithm with the COSI HBKE, but then the feedback was that may take a while till it actually gets standardized. So we shouldn't do that. There may be a lot of dependencies, unresolved dependencies. And so we put it out and put it into a separate document, which we then later extended to also support COSI, Jose and COSI. So what this document does is essentially registers an algorithm identifier, namely for this hybrid mode for use with HBKE, which refers back to the discussion that Brian triggered earlier during this meeting about the story for having one story for the use of chems, chem support, whether that would be HBKE based chems or some other mechanism. So that's all this document really does. So if you believe HBKE is the story, then you will obviously like that document because it gets you onto that path of traditional crypto, hybrid, and PQC. But yeah, if you don't find HPKey relevant for you, then obviously this one is also not relevant.
Okay, so we'll just take the discussion in the mailing list. There is a set of slides that they prepared, but Hannes has generously shortened to just the description. So. Next is Paul.
Is he online?
I don't. Oh, there he is, Paul.
Hey.
Hi, just a sec. You want me to do your slides, or you?
Yeah, please. I think that's easier. So I presented this formerly known as ECDH MAC-based signatures on IETF 119, I think. We got some feedback back there. We incorporated this, and it's still relevant. That's why I proposed it again. I have a colleague that's also working on this right now and helping me out, which is Micha. Let's dive into it. Next slide, please. Yeah, so the general idea here, or what's the motivation for this, is that in the ecosystems where we are using Jose-based algorithms, we mostly use regular signatures like ECDSA. We're working mostly in the wallet ecosystem, verified credentials, ISO MDoc, where this is used for two things mostly. First, for the data authenticity, the issue assigned part. That's the SD-JOT or the ISO MDoc issue auth. And then also for presenting this to verifiers or relying parties. So the key binding in SD-JOT, for example. There's a lot of, at the same time, discussions about privacy and whether we want repudiation or deniability. This has come up in the German architecture proposal for the EUDI wallets for the PIT, which is kind of the equivalent as a verified credential to EID cards, so an identity document, which is called within their authenticated channel, which is based on ECDH MAC and aims for reputable presentations. And it's also discussed in another topic, hierarchical deterministic keys, where this is kind of wanted because we don't have something like reputable signatures. So there are some people who want this. And so we looked at this and thought that it's worthy to specify something like that for Jose. Next slide, please. Yeah, maybe if we don't have much time, let's skip over that one. I just expect people to know on repudiation, and let's also skip over that one and just get to the point. We're not reinventing stuff here. We're using stuff that's well known and used in other spaces as well. We have something similar that is being used for COSI, like I would say in the ISO 18013-5 mobile driving license part, and we also have something quite alike in the extended access control protocol that's being used in the German EID card. It's a very basic combination of Diffie-Hellman key agreements. So the signing party and the verifying party both agree to a key using usually ECDH. The signing party then uses the shared secret, derives the key, and uses a MAC algorithm to sign whatever he wants, a verified credential, data, anything. And the verifying party then may check the MAC and knows that, that this is a designated verifier signature for particular himself, and he trusts that this is being done by the signing party because he himself is the other party who knows the shared secret, so the other party can only be the signing party. Therefore, he trusts the signature. Next slide, please. So we construct something, quite simple here, a designated verifier signature algorithm that consists of three components, similarly to like HPKE does this. We have a Diffie-Hellman key agreement, a key derivation function, and a MAC algorithm, and we combine these to a pattern for an algorithm identifier. And what we need then on top of that is some additional cozy headers and how to use them. We reuse the JWK cozy header for the signing party's key. We add a new parameter RPK for the verifying party's key and an additional optional nonce as a way to provide freshness by the verifying party if he doesn't use ephemeral keys. Additionally, we also describe an algorithm that directly uses HPKE within there because we're a signing algorithm. We don't do any encryption, but we use the underlying auth mode and the AED, to generate a signature with HPKE. And they kind of both work very similar. And we thought we put in both for the beginning and see how that goes. We tested the HPKE one with the Nimbus library. That was quite easy to implement. And the other ones at the top have been tested within the so-called wallet challenge in the German architecture. Wallet challenge, where several wallet implementers are kind of competing and testing different implementations from the German architecture proposal, which is referenced. Next slide, please. This is what a JSON Web Token using this would look like. It's quite basic. We have the set Jose headers at the top. We have any payload, and then we have a signature that only contains the MAC. So very simple. And next slide, we have the potential algorithms that we define in our draft. And that's pretty much it, I think.
Go ahead, Hannes.
Yeah, I'm surprised that Brian doesn't jump up to say, oh, this is actually, again, another option for doing the same thing. If you think back about the presentation I gave about the key encryption, it was the CAC that was used with the algorithm that you specified in there. If you, instead of an encryption algorithm, specify a MAC algorithm, you exactly get that. Done.
Does that point to me or to Brian?
To both of you.
Yeah, I think it's valid. There's one downside of HPKE because it actually does like 2 asymmetric operations, while the more simple one only requires 1. That's kind of the design how HPKE goes. So looking from a simplistic variation, first one is simpler, I guess. Or we would need to extend HPKE in a way that is not designed in the RFC.
You're saying there were 2, did I hear you say asymmetric or symmetric?
Asymmetric. If you use HPKE in the auth mode, then you need 2 asymmetric operations because you do 2 Diffie-Hellman operations.
I don't think.
The normal encryption with HPKE uses 1 Diffie-Hellman, and
It's
the
an ephemeral
authenticated.
static. It's an ephemeral. It's an ephemeral static Diffie-Hellman. In plus stuff.
The auth mode in HPKE, as I read it,
yeah.
adds an additional Diffie-Hellman operation.
But we're not. So what I was previously talking about is not the auth mode, but the regular mode.
Okay, then that would be different. Yes. Okay.
Hi, here is Guiling from Huawei International, Singapore. So it is nice to see your draft. This is the first time for me to know this draft. Yeah, because for me that I once did some academic research for designated verifier signatures. Yeah, quite some years ago. So I would like to have a close look on your draft. Here, one question for me is that I would like to know, yeah, for your proposal, did you consider some efficiency issue or something? Because for my knowledge, Jose may be more likely for IoT scenarios. So in that case, did you have some concern about the performance? Because sometimes like the DVS could be quite complex. Sometimes we need to use the zero knowledge proof to show, okay, which verify have the ability, to verify a signature. Others may be not able to do that. Yeah, this is my question.
I think if you compare the suggestion that we do, and if you compare it to ECDSA, that's our main comparison, then I think computation-wise, it does not differ very much. It's an additional key derivation and a MAC algorithm. But apart from that, that's different to the only difference to ECDSA.
Okay, thank you.
All right, Neil, do you have something really short while Lucas is coming up, and then John, you can go after him.
Really quick one then. I think this draft is limited to a single recipient, and perhaps it should just be clear about that if that is a limitation.
Yeah, that's currently the limitation, yes.
Okay.
I can make it clear.
John, go ahead.
One observation in one of your earlier slides, you said that hierarchical derived keys pointed to this. That's simply because we were trying to figure out how hierarchical derived keys could support the particular German implementation, not that we thought this was a good idea on the face of it. The other question we might want to think about the naming. This certainly isn't the only way to do designated verifier. I know there's a couple of other techniques. So we may want to clarify that this is a way of doing a designated verifier or something. I'm just concerned about the framing slightly.
Okay, so good afternoon, everyone. So I'm Luca, and 3 weeks ago, we released the draft titled Post-Quantum Traditional Hybrid Composite Signatures for Jose and Cose. And so I will briefly present this draft today. So let's start with a quick overview of what the draft is about. So we are registering new hybrid signatures, which combines post-quantum and traditional components. And so we adopted the composite approach, so similar to the one which is used in the LAMPS composite draft. And so basically, with this approach, the composite keys are treated as single keys, even though the signing algorithms internally use a sequence of component keys. Even though, yes, they use a sequence of component keys. And so this basically gives us some protocol backwards compatibility, because composite keys and signatures can be integrated into protocols without requiring any modification to handle multiple algorithms. And so we believe that this approach, the simplicity of this approach, is particularly suitable for Jose and Cose because it provides a straightforward implementation. And yes, we have a question.
Finish, please.
Okay. So yes, I think that this is the right approach for Jose and Cose. Next slide, please. And so here are the different composites that we are registering. So basically for the post-quantum component, we selected MLDSA, and for the traditional component, we choose ECDSA. So we defined 3 different security levels, ensuring matching the security level for both components. And while we could add more composites if there is interest in the future, we wanted to start with something quite simple and manageable. And you will notice that we also specify a pre-hash algorithm here. And so it is used when computing a composite signature. Next slide, please. Because as you see there, when computing the composite signature of a message M, the process involves building a message M prime, which is defined by computing the prehash of M and concatenating it with a domain separator before calling the different component signatures. And yes, so for the domain separator, it is used for binding the component signatures with the composite algorithms to avoid some stripping attack. And so we define it differently that what is done in the LEMS composite draft, because instead of using OIDs, which are not really used in Jose and Cose, we defined it as the octets of the ASCII representation of the algorithm header parameter value. And then yes, so last remark about the private key format. So there were some discussions recently on the mailing links about how to represent the private keys. And so in this draft, we choose to represent them as a seed from which we can then recompute the full expanded private key. And so we also define some key types. So the AKP EC and AKP EC2 for Cose. So AKP actually comes from the Cose MLDSA draft. So it means algorithm keeper. So we chose to align with this Cose draft. And for the associated parameters, we define some value for storing the public and the private keys. And so finally, we would like some feedbacks regarding different points. So how many composite algorithms should we define? What would be the best way to store the private key? And what would be a better definition for the domain separator? And also, do we want to separate a pure and pre-hash option, because we now have that option available for MLDSA? So, thank you.
All right, go ahead.
Hi, Deirdre, Sandbox AQ. I'm a co-author on the hybrid signature spectrums document in PQIP. I don't think we should do this. I don't think you should do composite algorithms, period. I think that if people need PQ signatures on their stuff, they may be able to just wait for fully PQ signatures. I think composite signatures are much harder than hybrid key agreement and hybrid chems. It's harder to deploy them well and securely and ensure their authentication properties across the whole cryptographic protocol that you're trying to assert. And they're getting very complex in terms of the whole cryptographic protocol that you're trying to deploy. I have issues with the composite signatures that are happening in LAMPs. I don't think the group should adopt this.
I agree this is more difficult than hybrid chem, but there are also some requirements from security agencies, for example, that really want people to not go straight ahead to pure post-quantum. So that could be a solution for.
Chris Katkowski, because it's more or less what she says, but it would be great to know about all those use cases.
Okay, maybe put that in the mailing list. Sophie?
Sophie Schmid, Google, same thing that Deirdre said. If we have to go to the details here, private key, always seed, pre-hash, do not use hash MLDSA. That way lies madness. It's a really bad thing to like fit into the rest of the standards. There's an option to pre-hash MLDSA directly if you're only using MLDSA, which is nice if you follow what Deirdre says. If you want to have the same hash to sign for both of them, just and in the protocol specify that you hash and sign a hash. Do not use hash MLDSA. It is not a good idea, in my opinion, to do it on that level. It will just get very confusing very quickly.
John?
Hi, yeah. So I'm John Gray. So I'm one of the authors of the composite signatures draft. So we actually do think it's a good idea, obviously, or we wouldn't be an author. We do have a lot of people that want to use it. What my comment was going to just be, you based it on the version -02 of our draft, so we should probably talk more and make sure that things are aligned because, yeah, we've updated the draft recently to use, we have a pure mode and hash mode. There will probably be more discussions on that, but whatever's decided, we should align. That's basically my comment.
Awesome.
Go ahead, John.
So there appears to be differing opinions about hybrid signatures depending upon which side of the Atlantic you're on. So far in the US, from NIST and NSA and other folks, they seem to have a strong opinion against doing such things. Perhaps in Europe, there are some agencies that want such things. So I find it curious that the composite includes P256, which most of the European agencies kind of don't want. So it seems like an odd match of algorithms.
So I'm having one last feedback. So regarding the attacker model, IETF is considering probably side channel, and side channel protection of the keys is not in the scope. And with a background in side channel protected hardware implementation and the timescale that is needed for implementing it, it might be worthwhile considering to use a classical existing implementation for as a component for protecting against a key leakage. So this might be an option to consider existing things, because before you start getting hardware side channel resistant implementations that can be really slow and might be a reason for taking this component as is.
Go ahead, Deidre, real quick.
Thank you. To your note, the CNSA 2.0 suite guidance for American national security systems says no hybrid signatures or key agreement for that, which is an indication of the NSA's confidence in MLCAM and MLDSA. For FIPS, there is no yay or nay on hybrid signatures yet. They are putting out guidance for hybrid CAMs. We're waiting for it by the end of the year. We've had less guidance from NIST on FIP support for hybrid signatures, if any. So just to point that out, but yes, in other governments besides the US government, standards bodies, or national security, there has been interest in hybrid signatures and hybrid chems more so than the American side. Yet, if a secure or protocol wants PQ authentication, it is less complex and more tightly scoped to do fully PQ single algorithm authentication via signatures than trying to do composite or hybrid or fused or whatever name that you're applying to whatever setting. So I just wanted to point that out.
Okay. Hannes, we have just a couple minutes if you want to cover this draft. While he's coming up, these 4 drafts are all individual submissions, and we will take to the mailing list what the resolution of them will be.
Next slide. I just wanted to give you a status update on this one. I presented the draft on the slide, Jose guidance document, and we did a call for adoption. That led to feedback saying that the scope was too large. We should sort of nail it down to one specific issue, and republish the document, which is the content of the draft that I showed on the previous slide. Next slide again. Then, so what's in there? It's about a habit that we observed, that some people, when they design their systems and their solutions, the key identifier, despite the fields in the header, they actually put some parts or all of it into the body of the payload, which means that the processor then has to collect the different parts, put them together to find the right key. And that's a real problem for implementations and also for security processing, because you also need to understand suddenly the content of the payload before you actually find the key to pass the payload. And that's what we describe in this document. And I'm already out of time. Sorry.
Okay, thank you. So with that, we have finished on time. There have been a number of documents here that were individual submissions. I'd like everybody to please comment, review them and comment on the mailing list about your thoughts on those. Also, the documents that have been adopted as working group documents need to be reviewed. Thank you very much. If anybody's interested in helping with doing things like Shepherd write-ups, if you could come up afterwards or send an email, we're going to need that real soon now. Thank you. Have a good day.
Everything that's old is new again.